Hello everybody, my name is Benjamin, and today we're going to be talking about this cabin that I made in geometry nodes. Showed it off a little while ago, but now we're going to talk about all of the internals and what the node tree looks like to build it entirely from geometry nodes. So let's get into it. Here we go, we've got the cabin all nice and pretty, and you can see the only actual geometry in the model is this cube. So we're not actually using that. We are using exclusively this one node, one geometry node's modifier right here. And so we can see we've got 3 values and then a selector. Selector, we can toggle the colors on and off. This is valuable, and we'll talk about this later for 3D printing, separating out groups of colors. We've got this seed value, all of the different noise and minor variations, log placement, grass and logs, and all the roof tiles all wiggle around with that node option right there. We've got the cabin number. This is also parametric. We can just change what number this cabin is. It's literally all that does. And then the cabin radius. We can do everything from itty bitty little outhouse with windows to big house, big and wide. So those are all of the variables that we've got here. Now let's move into what the tree actually looks like. And so you can see it's pretty large, but it's broken into fundamentally 3 main groups. We've got the log cabin, the wall generator, that actually puts all the logs in place. The roof generator, which puts the tiles in place and puts the slope of the roof in effect. And then what I'm calling the grebles, or all of the other add-ons such as the door, the number, the windows, and then also the grass circle, so the base. So let's start with the first one, just the log cabin walls. So just selecting just this one, and just so you know, I'm using Shift and Alt to switch between the different nodes here. So I just hold down Shift and Alt and I click on a node to preview its output. That's just shortcuts the node's output straight to the final output of the total tree, just for ease of use. It's not showing up here with the screencast keys. So anyway, this log cabin wall generator just puts all of the logs in the walls. And you can see we've got a few different variables. We've got the log length, diameter, the radius of the cabin, log placement, log angle placement, range, log diameter variance, and the number of rows, and the seed. So we're going to hop into this tree and see what those do. First thing you'll notice is everything is wrapped inside of this repeat function. And the reason for that, if we cut this, and we have this number slider here for the iterations. So what I'm doing is I'm iterating over the process that takes an individual cylinder and then offsetting each one over and then up. What this node group does is it takes this cylinder here and then it uses the radius of the cabin to determine the length of it, and then changes inches to meters. For a lot of these calculations I'm using this here. It's just dividing the input value by 39.3701. That just converts the values so that I can put input values in inches, and then all of the calculations will happen in Blender native metric units. Then we've got this other node group here, spreading the... What it's doing is it's creating a matrix transform that offsets each log to its proper side and angle. And so what it's doing is our angle is 90 degrees. So that's rotating from vertical to horizontal. Then it's wrapping the index, and the index is the number of iterations that we've gone over, but we're going to use this math node to wrap it between 0 and 4. So when the index counts up and it gets to 5, we need to wrap it back down to 0 so it doesn't, so that it iterates on 4 walls. And then what we're using that is the index switch is going to then pick from these 4 sets of transforms. They're all rotating around the X or the Y to lay the log down the correct direction, and then they're offsetting them by the Z and the X as appropriate to get to the wall. I'm using a multiply by -1 so that the whole unit is symmetrical around the center. So these last 2 transforms are doing the mirror image of the first 2. So that's what's going on there. Another simple node I'm using a lot is just converting degrees into radians, and that's just multiplying the input vector by 0.017454. All that does is makes it so that I can again use 90 degrees rather than having to use like 2 pi r, or in this case 1/2 pi, or pi over 2. It just simplifies it so that it's easier to read at a glance. So anyway, it's combining that transform, using that index switch to select the proper one for the index of the log, and then taking the Z offset from these to these nodes randomize the radius based on the diameter variance and the seed, but they're also based on the iteration. So that's using that to generate all of the noise in the size. As you can see, not all the same size, they're kind of offset. So that is generating the transform to put them in places. We've got another node group here. This one is just adding the variance for the angle and range. So it's multiplying random values, combining those values, make another transform. So can multiply those matrices together and get a total transform. So, and I'm going to show how all of these affect the outcome once we're done talking about the internal nodes. Next, I've got this, the input and the output of the repeat node. I've got these offset values, and they're plugged in. So like offset 4, that's vertical offset, that is coming then into offset 3. The idea here is I'm bringing in this value from offset 1, comes in here and then is added back in, and then that is this value then is split to come into the combine it here in the Z. So what that's doing is it's injecting a value based on the height. You can see that the randomized radius goes into this and adds to it, and then comes in and iterates through a few times. So what that's doing is that when log is placed, it's a random diameter. So then it comes around places 3 more logs. When it comes back to that first log, if we just use the standard consistent offset, it would intersect by a random amount. So what I'm doing is I'm storing that value and using it later as it comes through these offsets, so that when we come back to place the log on top of that first one, it will be the proper offset higher. So that's just a way of tracking that and getting it to iterate properly. And then we've got this set material node, and that's just so that we can set what group of materials this is going to be in. And here we're just using the log material. So that's what this does. And you can see most of these are plugged into values, not into the actual group input. So these are, I guess, the firm parameters that I've got set here, whereas the ones that you'd want to change on a general basis, those are plugged into the total group input. But you can see what they do. So like the length is just how long they are, the diameter is how big they are, and then you can see it's based on number of logs, not necessarily the height of the wall. Log placement variance, you can see that one is not plugged into anything because I've got it cut that improperly. So log placement variance is just the horizontal noise in its location. Then we've got angle variance, which is just the angle of the log horizontally. Then we've got diameter variance, which again is just how much different each log is, and then the number of rows determines how many rows of logs there are. So those are all the values that we're putting in here, and that is developing the logs. Next, we plug the output geometry of that into this node group here, where it cuts it to be roof shaped. And you can see it also fills in this center area. So let's take a look at what this is doing. There are primarily 2 groups. The first one is making this shape, just a squashed diamond. It's taking a cube and then rotating it by 45 degrees, and then it's scaling it vertically. So it's applying the scale factor. This scale here is making it more rectangular, scaling along the Z a bit, and then you can see it's squashing it with this one, and then this transform is just changing its original position, and then in the context of that transform, the next one is applied. So that's why it's applying this vertical scale after it's applying the rotation. So anyway, we're doing that transform, and then that is going into the mesh boolean here to cut the roof shape. Now, if you notice, that's not the only thing that's being cut. We're also cutting it with this shape, and this is another node group, and we can go and look at what that is. This one's pretty simple. Again, it's just taking the radius of the cabin, what it's supposed to be, adding some math to offset the proper amount, and tapering the sides. So it's all based on cubes. So you've got a cube for the top half and a cube for the bottom half, because what we are going for is the ends of the logs, when they are done with the walls, we want them cut at an angle. And so that's what this bottom half is. But for the top, the roof has a few extra logs that stick out and support the end of, or the gables. And so we want to have those longer and not tapered or cut in an angle. So we're just going in there, taking our cube, scaling it, transforming it up. And that's the top. And again, we're taking a cube, scaling elements, but using a position node, separating by Z and making it anything less than half. So we're only selecting the bottom ones to do that scale function, transforming it up, doing a mesh boolean to intersect them, and that is our shape. So that is the boundary of the logs all together. So that's the logs after they've been cut. But you can see we've got a couple other booleans going on here too, and they're just a fill for this, because this is going to be for 3D printing. The interior geometry is not part of what our end product is, and the goal isn't to be open space. So what we're going to do is we're just going to use another cube, transforming it up, setting that to log color again, and then we're just going to do the intersect with the boundary and the roof cutter. So it's just going to be the smallest shape, and then we're going to join it. So that way, when we print this, it'll be a solid block. It'll be exterior faces only. So nice. So that's everything that is in that node, and that ends up generating this cabin here. Up next, we've got the roof generator, and you can see we've got a whole bunch of nodes here. And you can also see it's generating the roof in two colors, and we've got a whole bunch of parameters. And let's actually run through these parameters real quick just to show you what they do. The first one is the tile length, and so that's the length down the roof of each tile. And then the height is then this one's actually the length. They're offset a little bit. And then tile thickness is just, again, like you'd think, how thick they are. The length and the height, these are being derived based on the cabin diameter variable. We've got a shingle overlap, and that's just how much the shingles are overlapping the next one. And then the width, again, similarly, we've got two different directions. We've got up and down the roof and longitudinally. And that's what this one does. We've got a tile variance. So we have a little bit of noise in the rotation of these tiles. We've also got the angle that they're set. Because by default, they'd all be at the same plane, but what we want is them to be kind of lapped over each other. So let's dive into this node group. So this one is kind of another large one, but primarily what it's doing is it's taking all those values, converting them into metric units, and then up here we're generating the actual tile. So here we go. We've got one individual tile, and what we're going to do is we're going to do a mesh to volume and then distribute points on that volume using the seed value for noise. We're going to realize those instances so that they're treated as a group, not as individuals when they're brought into this next one, which is convex hull. This is a really slick way to randomize the shape and give it a little bit of wear and asymmetrical shape to it without having a huge computational hit. Because what it's doing is the vertices, or the points that are going to be distributed across it, are not going to be all the way to the edges, and they're going to be imperfect. So we can capitalize on that imperfection when we're trying to make imperfect shapes. So that gives us our little screwy little tile. It's a little bit imperfect. You can see, yeah, move this seed around and it updates on the fly. And then we're setting that color, setting material right there. Next, we make a grid, and you can see it's just a flat grid based on the diameter value of the cabin, and we're cutting the diameter in half, so it's only going to be covering half of the roof. And then we use a transform to move it over so it's on one side of the roof, and we have a little bit of offset because of the size of the tiles, because on each of these intersection points or vertices we're going to have a tile placed. So we want to have the top edge of those tiles to be on the 0 point on the x-axis. Next, we do an instance on points. So you can see now we've got tiles on those points. And then you backtrack again, we've got a rotation here. And we're defining that rotation here, just adding a little bit of noise into that. So we're using the angle values we've put into it and adding in a few more so that we get a rotation on top of that. Then we're adding another transform after the fact that just gives us a little bit more control over the shape of them. And then that is then going into, that's going to be going into later functions that we are going to use to combine with the actual the gables and the trusses underneath. So okay, up next you can see we've got this transform geometry, and it seems to do a whole bunch right there. Well, what it's doing is it's combining transforms of two different kinds. So we're using this skew slope value, and it's going into this combined matrix. And by adjusting the different rows of these columns in this matrix transformation, we can do scaling and rotation and other transforms. But what we're doing here, putting this value into row 3 and column 1, we're able to skew the sides of the roof object. So we're not actually rotating it. And this gives us the distinct advantage of now the edge of the roof is vertical, and then on the other end it's also vertical. We're going to be joining it with the other half of the roof. So the way we do that is we just take this transformed geometry, rotate it around the Z 180 degrees, and then we join it back in, and there you go. We've got the roof. And so that's a really, really quick way to make a roof that's symmetrical and a little bit nuanced in its texture and shape. So let's back up a second, look at how these gables are. It's pretty simple. Like we've done a lot before. It's a cube. Transform it over, transform it down, so that the top surface of that will line up with the bottom surface of the roof tiles. And then that goes up here, turns brown, it's joined together and skewed. So altogether, pretty slick, straightforward way to put together a parametric roof. So there we have it. The basic, the minimum to make a cabin. I'm just going to change this value a little bit because I can see that the value we had on there for a second was just not quite doing it. All right. Nice. So that's everything in the main cabin. Next, we can move on to the greebles, as I call them. This is going to turn this rather plain cabin into the specific cabin we're trying to make. So first up, we've got cabin number. This is pretty simple because all it's doing is taking the radius and the number. The number is coming in as a value, and it's being turned into a string to curves, fill curves, extrude mesh, join geometry. So that's just this process. So the reason we're extruding and then joining is it extrudes it as a shape, but it doesn't include and join it back into the original face. So we're doing that as another operation. Merge by distance just cleans up, just a way of cleaning up some of this geometry. You can see it just removes some of these extraneous vertices. Then we're transforming it, and that's primarily just going to be moving it up to the right angle and then out so that it's on the face of the front face of the cabin, and then setting the material so that it's the color for the number. Nice and simple. Door generator makes this door, and this has 3 colors, and it looks like it's a little bit complicated, but again, our variables here define pretty much everything that we need to know about this door. And once we go into it, it looks again complicated, but fundamentally all it's doing is taking cubes, moving those cubes around, and cutting them out of each other. And then taking like this cube here, and then making it smaller, and then making it smaller again, and cutting it out. And there you go, we've got the screen cut out. And then doing it again for the bottom, and then the doorknob, it's taking values, converting them to metric, making a little sphere, transforming that into the position of where the door should be. And then we've got this here. This is actually doing a lot of the heavy lifting, because if we look at this, you can see the orange dot, the origin for this node tree is right in the center of it. But we actually want it on the surface of the cabin. And to do that, we are using one transform at the end that moves everything into place. And that's just dividing it, so it's moving it just by the radius out, moving it up by the height of the door, so the bottom is always at the ground level, and then making that into a single transform right here. So nifty way of doing it. So all of the rest of these nodes can be just putting things where they should be in relation to where the origin of the door is, and then after the fact we're moving everything to where the door should be. We don't have to track all of those offsets in the individual components. So that just simplifies it a little bit. Next, we've got this window generator, and we've got a window on both sides, and they're a little bit more complicated. You can see they've got a few more variables, but simply they're another case of moving everything around. And again, we're using a single transform to place the windows where they should be, in this case, we're actually splitting into two transforms that are one's rotated 90 degrees, the others or one's negative 90 and the other's positive 90, so that they start out here at the center, but then they are moved and rotated to their respective sides of the building. But the way these are put together is just we're just taking the values that define them and making cubes, setting materials, moving them over, making more cubes, cutting them out, and setting those materials. So that's making the window frame, and then these panes are actually a little bit cooler because they're just taking the outside shape that they should be, making a grid, transforming that grid, making a cube, and then instancing that cube on that grid, setting the material of these so that when we cut it out of another shape, the cut holes will then be the color of these small cubes. So remember this shape just that we derived from the frame? We cut out the window panes out of it. And the reason that that's so cool is that we can change the thickness of the dividers between the panes, and they update all of them. It's really super slick, and we can change the depth. All of this is just variables here in the panes, or the window pane. And we join it back with the frame, and then we move them over. So again, windows are pretty simple. They're just moving them around, moving cubes around, instancing cubes, and then coloring those cubes. Next, we've got the window box generators. These are very much like the windows. They're just on the ground and with a few parameters, nothing too crazy. And looks very similar. We've got a box, and then we are making these panel cutouts, doing a mesh boolean to make them cut out of the main box. And then we're making another transform. We're making then another derivative transform because we're placing one here and one in the back. And we're joining those together, setting material, and that is these boxes. Again, pretty much what we've been doing for all these other rectangular features. Next, we've got this little unit here. We've got like an AC unit and either a gas meter or something, just kind of, or maybe electrical meter. And so it's got this round shape, so that's a little bit different, but once we get into it, it's very similar. Because we start with making this radiator unit. It starts with a cube, and then we're setting that as the metal color, making another cube. So we're defining the size of this cube before we put it into these transform nodes. The reason for that is we can just define the size of it based on rigid numbers so that we don't have to worry about scale factors or any of those other things. We can just tell it what size it is and then tell it where it should be. We don't have to use scale if we don't want to. So here we're just moving it just in relation to this cube, setting the materials again, and then cutting it out. So that makes a nice little radiator. And then this exhaust or electrical unit, we're just making a cube, and we're making a cylinder. And we're rotating that cylinder and moving it a little bit. We're joining those two. And sometimes I'm using Boolean joins or Boolean unions or intersections. And that does tend to leave cleaner geometry that is more just nicer, watertight, and it's the best. However, when we're doing things like this, it takes longer to calculate those because it has to calculate every single intersection between the shapes. I don't really want to have a noticeable performance hit just for making this little greeble here. So that's why I'm using just a basic join geometry and not using a Boolean intersection. But then we're moving that again, and that's just in relation to the radiator. So the relation between the two units is set, and then I'm joining them together, so they're going to be treated as one unit. And then we're using this transform we put together, which is just based on the radius and the elevation, where like how far out from the origin and how far up from the origin we want this. I'm making this transform here, joining everything together. This one's actually not needed, so I'm going to just Control X to delete that with reconnects. And that's how we make these two units here. So that's all of the greebles. Up next, let's talk about this grass circle. It's a little bit of stuff going on here to make this nice little platform for our cabin to sit on. So let's get into it. So it's a little bit spread out. The only inputs it's taking is the cabin radius, so because it has to be bigger than that, and then a seed value. It's a grass seed, but that just determines the noise factor that we're going to be applying. So we get new grass every time. So what we're going to do is we're using this, and we're just having noise in the Z, and then the combination of position. The position and the Z are the factors that define this noise texture here. And you can see we can get different size noise on the grass. We can get rougher, and the smaller the number, the more gradual the ripples in the grass are going to be. And then again, we're going to be using the position of the vertices in question to we're just going to be scaling and combining. We're going to be taking just the X and Y components and the length. So what this is doing here, just if we step back for a second, what we're trying to do is trying to build the matrix transformation for the geometry, because this is actually, if we just take a quick look ahead, this is actually a plane. So what we're trying to do is we're trying to develop a transformation that turns this plane into that grass. And so what we're doing is we're taking the position and combining the Z seed value, and we're getting a noise just across the board. So there's noise across it. And then we're also going to be doing a position, but only the X and the Y components of it, and taking the length, so essentially the distance from the center, and you can see the center right there, out to every single coordinate in the X and Y. And then we are just going to make that a little bit. We're going to modify that value. We're going to just divide 0.08 by that value, and then multiply by 0.94. These are just kind of arbitrary values that I just played around with until they looked correct. And I'm going to be multiplying that by the noise. So what that does is the noise is going to be more stronger, it's going to have higher amplitude the closer it is to the center of this. So that's going to, here, let me just go back to seeing everything. So you can see it's smoother here and rougher in the middle. And that's pretty good. It just kind of adds some softness to it. But then we can see we're doing it again, but then we're going to put that same value where it gets greater influence towards the center of this circle. We're going to plug that into a gradient texture, a spherical gradient texture, and then multiply that by some values and subtract a little bit. And what that does is it makes it so that the is just adding a offset to all of the vertices, and that offset is larger towards the center. So what we get is a nice kind of crowned grass. It's kind of a little tiny hill. So if we made this bigger, let's let's turn this one off. So we've got our shape. I just want to show, if we made this bigger, we get more of a hill. And if we make this one bigger, we get more noise. And if we make this one bigger, we just get more detail in our noise. Same thing here. And then we can have this add offset, and that's just any flat up and down. Nice. So that's just compensating so we're at the right height. And then combining, that's just a Z offset. We're not trying to move the X and Y at all. We just want the Z offset on that original plane that I showed you right here. And then what we're going to be doing, so we're taking a grid and we're subdividing it, and then we're setting the position based on all of those offsets we just talked about. We're using these here to select just the edges. And you can see the way that works is it's just selecting the ones with position greater than the negative 0.02 and have edge neighbors that are not equal to 1. So that's just essentially selecting the vertices on the edges, and it's not setting their position. And so that's really slick because what it's doing is it's selecting all of the vertices except for the edges to make this transform. The reason that's really slick is when we go to extrude it, what we're going to be doing is we're going to be extruding this mesh. And if you remember when we did an extrude earlier, I said that it only extrudes the sides and bottom, or the final shape, and it excludes the original. Well, what we're doing here is we've got this with the edges exactly the same as where they were to start with. Exactly in this position. That coincides with the edges of this cube, or this extrude here, which has all these edges. So when we join it, it's a watertight mesh. We just have to merge by distance, and there we go. We've got a rectangular solid that has a noise texture applied to the top and no holes in it, which is super cool, because what we're going to do next is we're going to take it from a rectangular shape to a circular shape. And let me just show you the shape. We're going to make sure that it fits inside of this slab. So it's not going to be too tall, and the grass is going to be like sticking up into the cabin in weird ways. So this is just like we've done before, using values from the cabin radius. We're making a cylinder, and then we're moving it around just a little bit, and then we are cutting the intersection between those two shapes. So we get a circle and we get the tops cut off this grass here, which the cabin's going to be sitting on top of that, and it's not a big deal, but it makes it so that if we were to have a very sharp pointy noise function coming into this, it would kind of just cut the tops off that a little bit. And then we can see it's setting that green. But that's only part of the nodes. You can also see that there's this group here for making the curb. And in my opinion, this one is a little bit cheeky, but is a pretty slick application of not having to model the curb. But anyway, let's get into it. So let's start with this string to curves. And we can see the answer is 4. And that's just a string made into curves. Transforming it a little bit, so now it's rotated. If you look at it, it's not lined up with anything quite right. We're realizing it. And that's just because the inside and the outside of the 4 are 2 different shapes, and we want them treated as one shape. And then we're also making a circle. And if you notice, this circle is very similar to the size of our original disk. That's going to be important. So what we're going to do is a curve to mesh operation on this circle, but the profile curve is going to be the curve that is 4. So look at that shape. And yes, if you look at it, it's just 4. Rotated around because I thought that it made a nice little like beveled slope side, and it's pretty good. So anyway, transform that up so that it lines up with the curb, make it look like concrete, and then join it with the grass. So now we've got a curb around our grass that's beveled and round and nice, and there we go. So those are all of the individual components. And then we've got this little switch here. This is if we are wanting to just have everything one color. And so I'm using this generated, this texture called generated cabin. And all that is, it's a, let me show you. It's just using ambient occlusion, inverting the color, making a color ramp, and then making that the difference or the factor deciding between orange and blue. And so that way, the more occluded or more in a corner a vertex is, the more blue it is. So it's nice for visualizing the actual shape of this cabin. And then if you don't want that, got that switch there, so you can have it all broken out into the individual colors for the different parts. And then we've got triangulate, that just goes one quick run through at the very end to make sure that everything is as clean a geometry as we can get. Yeah, as clean as you can get with the methods we've done before. That just helps just make the slicer a little bit happier. So anyway, that is all of the steps and parts of the geometry nodes that I used to make this cabin. And you can see it's a pretty simple little cabin, but it's entirely defined by variables, and that's the special part. So now that this is all done, one thing you might want to do is 3D print it. So that is actually another bit of nuance that we can talk about here. So standard STLs, which is what a lot of 3D printers or 3D printing slicers generally use, don't actually have surface information. So there's no colors, no textures, none of that. So what we can do is we have to use another another file format to be able to export that data properly. Now this is a little bit determinate, or a little bit based on what your slicer can do. I'm going to use the OBJ file type, and I'm just going to make sure that I have the cabin selected. Export OBJ. I'm just going to drop this here in this folder. Cabin node tree output and selection only, scale of 1000. That's just for converting between Blender native units and the STL file units. So I'm going to make sure I get object material groups. Object groups would be it's good to have, but material groups is going to be important because that way we can get all of this color data baked into our output file. So there we go. Now let's move over into Bamboo Studio and see how that turned out. All right, so we've got the object output. Let's just drag and drop that in. And now we've got this object file import color options. So the one downside is the way we exported it doesn't make it very clear what these are. So I'm just going to go through and set them all to different materials. That way it's not going to combine any of them. We can just deal with it in post. Yes. Alrighty, let's check the scale factor. Okay, so the scale on this, I guess, could be a little bit smaller. Let's say and then F to lay on face. And I prefer to turn off the prime tower. I'm not exactly sure what the use is for that, but for the cases I have, it's not necessary. So anyway, we've got this cabin and it's in atrocious colors, but we can see that it is input into here. So we've got these overhangs. They're definitely not going to print right. I'm going to use auto tree, and I'm just going to leave it at default for now. And on build plate only, because I don't want to have to be removing supports from all this grass. So let's slice it and see how this turns out for the first run. It's going to be a little bit complicated because having 8 colors and so many vertices, you can see it is complex. You can also see how it's anchoring each of these shapes inside the model. It's really fascinating. However, you can see it's printing out all of the different parts in the different colors, just like we wanted. And there are some parts like this, this unit here, this cylinder, it's not supported because we chose to have on build plate only. That might be a problem, and it might be best to leave that option unchecked. All right, now we've got a little bit more support in there. You just have to remove that, and that's that'll just be down to personal preference, whether you want quality or ease of removing supports. But anyway, that is the cabin and all of the steps to make it the way it is. And then obviously what you can do is in your preparation, you can change all of the different filaments and change what they're mapped to. So I just set 1 through 8 as the colors, but then you can just change, like, oh, I want this one to be pink. Okay, that's all down to what you're slicing and what filaments you're going to use. So what you can do, this has 8 colors and it's atrociously colored here, but that's fine, because the important thing is the colors actually don't matter here. As long as they're the correct material, which I've got the first 8 are all PLA. So they're all going to have the same settings. So when we go into print, we only have 1 AMS on this printer. So what I can do is I can just go through and change these colors. And because we've got every color broken out, we can change all of the colors in post. So I'm going to say, let's have black roof. And then this purple here, I'm going to make that white. So that's the AC unit on the side. This this desert tan. I'm actually going to make this one desert tan. And then this one I'm going to have white, so that's the number. The teal, I'm going to have green, so that's the grass. I'm going to have white for that. The red, I'm also going to turn, yeah, desert is good for the logs. The blue, yeah, I think I'll have that as black. All right, so there. Now we've gone from 8 colors down to 4, and we can print this on the AMS. Now, because it is sliced for 8 colors, it's going to be a little bit more travel and print color, or color changes potentially. However, it's going to print just as you could expect. So there you have it, all of the steps from start to finish, from first geo node to the getting ready to slice it and print it on the 3D printer. This has been a long time in getting this video out, but it's out now, and I hope you guys like it. If you're still watching, it must mean you like some of this. And so I've got this file, the Blender file with all of the nodes, as well as this file that I just sliced, the Bamboo Labs sliced model, all the colors in it already. I'll have both of those linked on my Patreon down below if you want to check those out. And yeah, if you want to keep seeing videos like this, I'll try and keep getting videos like this out. Also, shout out to all you crazy people. Thanks for over 200 subscribers. That was exciting. Anyway, thank you so much for watching. I'll try and get some more stuff together and get ready to show you. But till then, see ya.